Well, hello guys, welcome again to this video regarding game development. The last video I showed you that how did I create the map, and in this video I'm gonna show you how did I implement the physics of the world here. So before I start doing that, let me show you a little demo. I'm gonna show you this while it's running, and I'm gonna use DirectX rendering here. So this is the executable. I'm gonna run that. I'm gonna say test here, and as you can see this little ball bouncing, and it changes its color when when it changes its direction. Maybe one ball is not good enough. I'm gonna increase that. So let me go to processes and end task and the process. That's it. Okay, so this is just for the sake of the example here. So instead of creating one of these, I'm gonna create 50. I'm gonna build that. I will not run it right away because I'm gonna use hardware acceleration. So double click that, test, wait a few seconds, and there we go. Okay, so we have about 50 of these. Okay, and as you can see, the balls are bouncing, and now it's a little bit messy because there are lots of objects. Usually in the game, I don't think you'll need about 50 objects to render here. Anyway, so you get the idea. So I'm going to show you how did I do that and how these balls can bounce and change direction and stuff like that. It's not that difficult to do actually. You just need to understand what is need to be done. Okay, so end task, and okay, so let's go back to our code. Okay. Now, okay, so first thing before I start here, I added to my project two PNG images, the dummy ball left and dummy ball right, as you can see them here, and this color here is transparent. Sorry, the white in the corner is actually transparent. Okay, and yeah. Now, so let's, before we start, well, let me see. Okay, so now you see the Project Explorer. You go to the module. Last time we discussed the general operations and the map. So let me show you what did I do here in the map first. Now in the map I changed the code a little bit, and here I moved a number of variables here, and these variables are view x1, view x2, y1, y2, and these represent the window of the view I am gonna display to the end user, and view x shift and the view y shift, and these will help me identify the shift needed for the object. Okay, and later on the rest of the code is almost the same for rendering the map. Okay, only the definition of these variables is not here anymore. Okay, now creating the random map is a little bit modified here. Okay, so first I created an empty map here, as you can see, and then I created a line at well, some of this code is just a combination of other tests. So basically this one, let me remove that. Probably I will need to remove this one. Okay, so that you don't get confused. So here I'm generating a random number, and if the random number is greater than 70, I'm going to create a number of blocks in the middle so that the balls can hit and bounce off these. And other than that, I'm going to create the bottom of the area that the balls will be moving in. Okay, and finally I'm going to create the two columns here. That's all. Okay, so that's all to it. Let's go to general operations. Okay, so what happens here? What I did here now, in the rendering subroutine, I added some testing code, and the testing code is surrounded by these uh, smaller stars and ends with this one, greater than star. Okay, so what am I gonna do here, or what am I doing here? I'm creating a list of base creature. This is the basic class that will allows me to create multiple, let's say, characters, and here I'm calling them creatures, and later on I'm gonna use that class and create different characters, and each character will have its own, let's say, behavior. Okay, so what am I doing here? I'm creating a new creature, and I'm setting the location of that creature or character here to be random value, and for x and for y. And now I have something called acceleration. We'll see that this will allow us to specify the direction of this character. And then I am going to add this to the list. I'm going to reduce this to, let's say, 29, so that we can get about 30 of these. And ix will tell me what part of the map I'm looking at. Anyway, so the rest of rendering is almost the same here. What am I doing is I am looping on all the objects I have, and then I'm just updating the location. I'm calling the update location. We'll take a look at that. It's not hard. And finally, after rendering the map, we are rendering the objects. That's all. So now let's go to the actual work. And the actual work can be found here, and it is the basic creature class. Now let me explain the this one here. First of all, we need to define here the creature x direction. Well, and by this I mean what direction is the character facing? Is it facing the left direction or the right direction? I am going to need that later on in order to identify which frame to render. Okay, so I'm going to use this and this. Okay, this is the first. Second, we have the a number of variables is rendered is used here to identify whether this character will be displayed or not. If the character goes out of the dimension of the let's say the screen of the map, not the screen, it will there will be no calculation for its location, and there will be no rendering for it. Okay, now here we have another one which is affected by gravity. Some characters might need to be to fly, and they will not be affected by gravity. Some might need to have this behavior. Okay, map x will tell me the x location of the character within the map, and map y will tell me the y location within the map. Acceleration y will tell me how the y will change. So basically it will be if the character is falling, so this will be a positive value, and it will cause map y to increase. Now if the character is jumping or bouncing off, this will be the negative value, and this will be added little by little, and the location of that object will go up. Okay, acceleration x is similar to acceleration y. Now stand on bricks. Now here I am defining the list of blocks that I will use that your character can stand on or bounce off. Okay, so you need to specify these. Okay, and here I am using a list because it could be multiple blocks, not a single block. Okay, the direction is used here to identify whether the character should face the right direction or the left. And render stage, well, and when you are rendering your character, you might need, for example, display multiple images to to show that it is having a motion towards the right or towards left. So I'm going to use this render stage here. We have the creature width, we have the creature height. Okay, I'm going to need these, and I have lift shapes. Now these are the actual images that shows the lift motion, and right shapes, these are the images that shows the right motion. And can bounce, well, I created this in order to have two behaviors. The first one is bouncing, and the other one for object that does not bounce. Okay, so now half width and half height is actually the half width and half height. I created these in order to speed up some calculations and stuff like that. So let me see here. Now the new method is used in order to initialize the class, in other words, initialize our creature or character. So what happens here is I'm saying that my character should be rendered here, and I'm specifying the map X and Y. I'm specifying the acceleration. Acceleration Y means that it will not fall, okay, unless it's affected by gravity. Then it will have acceleration to fall. Stand on the blocks. I'm initializing this array, and I'm specifying the only type of block that my character can stand on, and it is a brick. So as you can see here, it's a brick, a block. Okay, so the direction, my character is faced to the right. Render state is 0 because I have only one image. I'm going to show you later. Creature width and height, and half width and half height. I'm using these subtractant 3 for well, this is to address a small problem. Don't worry about this for now. But usually I'm using this to address some kind of edge detection problem, something like that. Don't worry about it now. Is affected by gravity. My character will be affected by gravity, and here I am defining the left shapes and right shapes, which are the images of my character, and can bounce is true. Okay, now here I am adding just one image for each state. For moving left and right, I'm using just one image, and that is the dummy ball to the left and dummy ball to the right. These are just for testing purposes. Now let's go to the important part, which is update location. What's happening here is as follows. When you want to update the location, first you check if it is rendered. If it's not rendered, you don't need to do any calculations, so just exit. Map X is updated by the X value, map Y is updated with the Y value, and now we are going to start on calculating some variables here. So top edge is gonna find me the top edge of the creature or character. Bottom edge is gonna be the bottom location of the character, and left edge and right edge it can be calculated like this. Now the thing is that we need these top edge 16, bottom edge 16, and so on. These are calculated by dividing each one by 16. The reason for these is that you want to find the location mapped into the array, the map array, okay? And each block or element in the map is actually a 16 by 16 block, so you need to do a mapping between the actual map X and the stored game map. Okay, so this will do the thing for you. Okay, okay, let me stop for a minute. Okay, let me continue that. Anyway, so I said that you need to do a mapping between the actual character X and Y location and what is stored in the game. And the game map coordinates. And each block in the game map is actually a 16 pixel, 16 by 16 pixel. Okay, so now I'm gonna check to see if the object is within the bounds of the map. So here, if the object is out of the if the x, the right edge or left edge of the object is out of the range of the map itself, not the display, then what you have to do is to say that this object is no longer, or this character is no longer valid because it's out of the actual map, so don't do anything. Same goes for the top and bottom edges. Okay, and now let's start to see. Let's start working with the acceleration and stuff like that. So if is this character affected by gravity? Now if so, then check the y acceleration. So if the y acceleration is greater than 0, in other words, greater than or equal, in other words, the character is not jumping or bouncing off anything, in that case all you have to do is this. You are gonna check the bottom of of your character. Maybe there is a brick or something it can bounce off. So here I am checking, I'm doing a for loop here on all available bricks, and if I found something that my character can bounce off, so here I'm checking that the left edge and the bottom left side and left bottom side of my character are show this here, or the right bottom side of the character is actually something you can stand on, or my character can stand on, then in that case I'm gonna check the following. If it is if this character can bounce, then change the acceleration. Okay, so if so this will have the bounce effect. Otherwise, if this object does not bounce, make its acceleration 0 and adjust the map y to be like this, and this will have the effect to make this character stand exactly on top of the brick. Okay, yeah, also mark this this as processed and exit the for loop. Okay, now if there is nothing processed here, this means that this character is standing on thin air, so basically it should fall. This is why we are saying that acceleration y plus 1. It means increase the acceleration so that the character falls. Now we don't make the acceleration go have very large values. The maximum value here is 10, and beyond 10 it's gonna it will not go further, so it will have a limit. Okay, now let's go to see the other situation. Now if the acceleration is in fact negative, in that case we want to check the top brick and see if there is something on top, so that the ball should bounce off the top in that case. So the same technique goes here. I'm gonna check if there's something on top, and now I'm gonna check the left top edge, as you can see here, and the right top edge, as you can see here. And if so, if it is bouncing, then change the acceleration again. Otherwise the acceleration equals 0. And then if it's not accelerated, okay, I guess I need to make this 1 instead of 4.5. Yeah, okay, so yeah, that's it. And yeah, this is how you do it. The same technique goes for the X and Y. Okay, except that there will be no acceleration change. For bouncing status you will use something like that, but for X and Y this part will be neglected because you don't want your character to bounce its motion. Okay, anyway, if we look at this, if the acceleration is on the right, then change the direction of the character to the right, and the rest is the same. Check that on the right top edge, that there is something that you are supposed to stand on, and also this means that it will stop you. You cannot move forward. Here you are gonna bounce, otherwise you will not be able to move. And yeah, and uh, and adjust the location. Same thing goes here. Change the direction. Wait a minute, this one should be right. Yeah, this is the right direction, and this one's the left direction. Yes. And now you will also reverse the acceleration if you are if the object should sorry, the character or the creature should bounce. Okay, and that's it. Okay, now the last method, which is rendering the creature. Now, if this creature should not be rendered while rendering it, so just ignore it. Now here, this if statement will check that the creature is within the bounds of the display. Okay, it could be within the map boundaries, but it might be off screen, so in that case don't render it. Anyway, here I'm checking the direction, and according to the direction I'm selecting the shape, for example left shape or right shape with the correct render stage, and drawing that into the screen. Okay, yeah, so this is it. This is the code. It's not that difficult. Okay, so I'm gonna build that. Okay, and here I'm having a gate lib DLL. I'm gonna run this, double click that, press test, and let's see. As you can see here, all these balls are bouncing, as you can see, and it has this yeah, maybe I need to put the balls on sorry, I need to increase the maximum value for acceleration to make it jump, to make these balls jump higher. Okay, so let me see. This base creature, where is the value? 10 acceleration Y. I'm gonna make this about you know what, instead of that I'm gonna change, where's Y? Instead of this I'm gonna make this 0.5 or maybe 0.25, I don't know, make it 0.5, right? And the other one, where's that? There should be another one. 0.5, okay, so this will have a similar effect. Okay, so now let's go back here, double click here, press test, and see how it's gonna work now. You can see now you are getting a better behavior here now. Okay, and this is the physics engine for now. Of course this is not complete, there will be more work that goes into that. Okay, I'll try to do next the controls, and yeah, I'll try to add the user controls, the keyboard controls and stuff like that. It's also something very easy, and assign that to a single character, and probably after that we will start to work on the character itself. Okay, and later on we might get to work on the enemies. Okay, so check out the website www.mka-soft.com to download the source files and check out the tutorials and videos, and leave me notes about this and tell me what do you think. Yeah, thank you and have a nice day.